In this video, we're going to complete 3 questions that involve synthetic division. And the first question is asking us to find all the factors of the polynomial f of x. And they're given us a factor to start with, which is x minus 2. And we need to use that along with synthetic division to figure out my remaining factors. So, the first thing that I'm going to do is take my factor, x minus 2, set it equal to 0, and solve it for x. So that goes away. I'm left with x equals 2. And the reason we did that is because we need the 0 that matches up with that factor to use for synthetic division. Now, another thing that you need for synthetic division is the coefficient, or are the coefficients of all these terms along with the constant. So I drop those down. That'll be 1, 3, negative 4, and negative 12. Draw a line here, and then I put my 0 up here in a little box. I drop down my 1 right here, and now I'm ready to do the synthetic division process. So I take 2, I multiply it by 1, that gives me 2. I add these together, I get 5, and then I bring it back to the 2. 2 times 5 is 10. I add these two together, I get 6, and I bring it back to the 2. 2 times 6 is 12. Add these together, I get 0, and this number represents my remainder, so I box it off. So when I come up with my quotient, well, now my 6 is going to be my constant. My 5 is going to be the term that's linear, or with a degree of 1, so I'm going to write 5x. And then my 1 is going to be matched up with my quadratic term, or the term with a degree of 2, so that's going to be x squared. You could have also looked at the dividend and saw, like, we have a degree of 3 here to start, right? Well, the quotient is always going to be one less degree than the dividend. So if this is a degree of 3, then this has to start with a degree of 2. So you could have worked from left to right, and that would give you the quadratic that we need to factor. So to factor this, we take 6, and we think of all the factors of 6, right? So that's going to be 1 and 6 and 2 and 3. 1 times 6 is 6, 2 times 3 is 6. But we need the pair of factors right here that also add together to give me 5. So 2 and 3 add together to give me 5. So I'm going to use those two numbers to create my two factors. It's going to be an x plus 2 and an x plus 3 because both of those numbers are positive. And these are the remaining factors. Now if you look back at the dividend, like I said, we have a degree of 3. That also represents how many factors you're going to have. So we have a factor here, 1, and then 2 more down here, so that's going to be 3 total factors. In the second example, we're asked to do the same thing. We're given a factor, and then we're also going to have a polynomial here that we need to divide this factor into to get the other 2 remaining factors. Because we have a degree of 3 here, that means we have 3 total factors. So the first thing I do is take my factor, set it equal to 0, solve it, and get my 0. So there we go. We're left with a 0 of x equals negative 1. Now we take all the coefficients of my terms up here along with the constant and set it up in a row with a line underneath it. And I also put my 0 up here with a little bracket around it. And I'm going to drop down my 3 and start the whole synthetic division process. Negative 1 times 3 is a negative 3. I add these together and I get 8. Negative 1 times 8 is a negative 8. I add these together, I get a positive 4. Negative 1 times 4 is a negative 4. Add these together, I get 0. That's the remainder. And we would expect this to be a 0 anyways, because anytime that we're checking to see if a factor is truly a factor of a polynomial, it means that we're going to get a 0. So because we're getting a 0, like, that's what we're expecting to get. So if you get anything other than a 0, then you probably did something wrong in the synthetic division process. Now, because our degree is 3 up here, the quotient of my division process here is going to start with a degree of 2, so I'm going to have 3x squared plus 8x plus 4, and the remainder is 0. Okay. But now I have to factor this trinomial, and it's a little bit harder because I have a number other than 1 in front of my x squared. So what I normally like to do to factor these types of trinomials is the box method. So I set up a box like this, and I take my first term and I put it in my top left hand corner, and then I take my constant and I put it in my bottom right hand corner every time those go in those two spots. Then I multiply them. So 3 times 4 is 12, and then I have an x squared, and I put it down here in the bottom right hand corner outside of the boxes. Now I have to come up with all the factors of 12. So that's going to be 1 times 12, 2 times 6, 3 times 4. And I want to figure out which pair of these factors add together to give me 8x. So that's going to be 2 and the 6. And remember, we're going to have x's with these two. So I'm going to plug these into my boxes here. And it doesn't matter which one we put them in. I could have put the 6x up here and the 2x down here. We'll still get the same answer. Now I'm going to factor out the greatest common factor from this row. So the part that we could factor out is going to be an x, and then we take the GCF out from this row. The number that we could divide into both those is going to be a 2. So that's going to be one of my factors, x and then the positive 2. We do the same thing going up in the columns, so the GCF going up between these two numbers is going to be a 3 and an x, and then between these two terms it's just going to be a 2. So that's going to be my other factor, 3x and then a positive 2. And that's the way I like to factor when I have a number in front of the x squared that's not a 1. And that will give me the final two factors along with this one right here. So we get a total of 3. This last example is asking us to do the same thing. We need to come up with the remaining factors of this polynomial. Now, we're given a 0, which is x equals negative 3. Basically, it's coming from x plus 3. Okay, that's the factor. However, we're going to still use the 0 to do synthetic division with this polynomial. So I box that negative 3 up over here, and then I want to use all my coefficients of these terms to set up my row of numbers. But there's something a little weird about this. There's no x cubed term. That's because there's a 0 in front of the x cubed. If you're taking 0 and multiplying by x cubed, there's no sense of writing it, but we still need to hold that place. So I'm going to take all my coefficients and my constant and start to write them from left to right, but I plug in a 0 where that x cubed term would go, or well, that x cubed coefficient would go. And then I finish writing the rest of my numbers. I draw my line, I'm going to drop down 1, and I start the whole synthetic division process. Negative 3 times 1 is negative 3. Add these together, I get negative 3. Negative 3 times negative 3 is 9. I add these together and I get negative 18. Negative 3 times negative 18 is a positive 54. I could add these together and I just get a positive 40. I bring it back to negative 3. I do negative 3 times 40. I'm going to get a negative 120. Add these together, I get a 0, which was expected, and that's going to be my remainder. Now now we got to come up with our quotient. Because our dividend was a degree of 4, I'm going to start with a degree of 3 here, so that's going to be a 1x cubed, and then a minus 3x squared minus 18x plus 40. Okay, I don't know how to factor this, so I'm going to use my other factor up here to do synthetic division again, and then it's going to break it down to a quotient with a degree of 2, which we will be able to factor. So the 0 that matches up with x minus 2 looks like it's going to be a positive 2. So I put that over here, and I drop down all my coefficients, draw my line, and I'm going to get ready to start this synthetic division. So I've even brought down my 1, and we go to this too. 2 times 1 is 2. Add these together, I get negative 1. Bring it back to 2. 2 times negative 1 is negative 2. Add these together, I get a negative 20. 2 times negative 20 is a negative 40. I add these two together, and I have my remainder of 0. And I'm going to write my quotient over here. It's going to be x squared minus x minus 20. And I'm going to factor this. So I have to come up with two factors of negative 20 that add up to be this negative 1. So I'm going to hold off on worrying about my negative for a minute. I'm just going to think of all the factors of 20. So that's going to be 1 times 20, 2 times 10, 4 times 5. Okay? And now, like I said before, I do have to have one of them negative. But I also have to have these two numbers add up to be a negative 1. So since the sum of these two numbers has to be a negative, I'm going to make my bigger term negative. Because when we add all three of these pairs together, I'm always going to end up with a negative number. So the one that works in this situation is going to be this pair. So my other two factors will be x plus 4 and then an x minus 5. So I have two factors here. This is my third and this is my fourth. So I have a total of 4 factors for my polynomial.